Hello everyone. In this lecture, we want to do a little bit of problem solving. So we want to use all the things that we have learned so far in calculus. It says find the slope of the tangent line to the curve y equals x squared minus 4x plus 4 at the point A, whose coordinates are 3, 1. And from there, write the equation of the tangent line at that point. Okay, we know a tangent line is a line that touches a curve at only one single point. And this graph is like this function given here is a quadratic function whose graph is a parabola, and it can easily be actually drawn. The vertex is actually located at 2, 0, and it's a parabola opening upwards. The y-intercept is 4, which you can easily find it by setting x equal to 0. And in anyhow, the parabola can be drawn. It's not a big deal. But finding the slope, in the past, we used to find the slope using limits. And we can still do that. I'm not saying it cannot be done. So we can say m sub t, slope of tangent, is a limit of f of x minus f at a over x minus a when x approaches a, of course. This is the formula for the slope of tangent, okay? And in this particular situation, we have a limit of x squared minus 4x plus 4 minus f at 3, okay, which is 1 actually, and then divided by x minus 3, and x approaches 3 basically. So that is what we are dealing with here, because f of x is a quadratic function, and if you sub in 3, 3 squared is 9, 9 plus 4 is 13, 13 minus 4 times 3, 12, which is like 1. That is the y-coordinate of the point. And that means that this point, point A, is actually a point on the graph. And this is very important. And we'll see in our future, like more advanced problem solving sessions, we'll see that if the point is not on the graph, we have to solve the problems differently. Okay, so we are finding this limit, and if we can find this limit, that will be the slope of tangent. So we're going to say m of t, or m sub t, equals limit of x squared minus 4x plus 3 over x minus 3, x approaches 3. If you sub in 3, the direct substitution method is not going to work because it gives you 0 over 0, as 9 minus 12 plus 3 is 0. So this is obviously indeterminate form. So we need to use a technique of limit computation here. And the technique we are going to use is going to be the factoring technique. So we're going to factor the numerator. It's going to be x minus 3, x minus 1, all over x minus 3 when x approaches 3, right? Two numbers add up to negative 4, but the product is positive 3, or negative 3 and negative 1, okay? And now when you simplify x minus 3 from top and bottom, you get a limit of x minus 1 when x approaches 3. And this time, direct substitution method, of course, works. So we do find the slope of tangent to be actually 2. So slope of tangent is equal to 2. Now, we have learned the differentiation rules. And we know that slope of tangent is actually f prime at a, okay? And this is an important formula, and I keep repeating this. M sub t stands for slope of the tangent line, and the f prime at a is the numerical value of the derivative of the function at x equals a. In this case, a is, of course, 3. So this a is the x coordinate of point of tangency. And f prime at a means we are evaluating the numerical value of the derivative at x coordinate of point of tangency. So what is the derivative of this function? We can say f prime of x equals y prime, and that is 2x minus 4. Very easy. And how hard it is to find f prime at 3? It's not that hard. So we're going to say 2 times 3 minus 4, and that is going to be 2. which is the slope of tangent. So you see that in a couple of lines, thanks to our knowledge of derivatives, we can find the slope of tangent. But if we didn't want to use the differentiation rules, we wanted to do it the traditional ways using limits, then it would be like the same answer, of course, but it would be longer. So this is the slope of the tangent line. And now it says use this answer to find the equation of the tangent line. So we're going to say y minus y1 equals m sub t times x minus x1. This is the point slope form of the equation of the line. We learned this in junior grades. Slope is 2 clearly, we know that. X sub 1 is actually 3. That's the x-coordinate point of tangency. And y sub 1 is actually 1. So we just substitute them. We're looking for the equation of a line whose slope is 2 as per our calculation, and it passes through the point A, 3, 1. So that's how we write the equation. So this is going to be 2x minus 6 plus 1. So y would be 2x minus 5, final answer. This is the equation of tangent line. So you see that as soon as you find the slope of tangent, the rest of it is like a grade 10 kind of question, okay? But how do you find the slope of tangent? You can use limits or you can use differentiation rules. The derivative of x squared minus 4x plus 4 is 2x minus 4, okay? So this was one example I wanted to show you how we write the equation of a tangent line. And if you draw the tangent line, actually, it's going to look like this. It's going to be a line like this. It's a line whose slope is 2. It's rising from left to right. The y-intercept is negative 5 right here. And I can even label it 2x minus 5. That's the tangent line. I'm going to show it here. And as you see, it is intersecting the curve at one single point, which is point of tangency. This point A is known as point of tangency, okay? In the next exercise, it says write the equation of normal line. Okay, so this was tangent line. It was saying write the equation of tangent line. This one says normal line to the curve of y equals 1 over x, which is a hyperbola. That's what it's called. At x equals negative 2. Now, normal line, see, if this is the tangent line, all right, now you may say, okay, what is the normal line? Normal line is a line that is perpendicular to the tangent line, and it passes through the point of tangency again. So if you draw a line like this, let me use another color here, perhaps this blue is good. So see, this line is called the normal line. Okay, normal line is always perpendicular to the tangent line. So this is tangent line, all right? And normal line is perpendicular to the tangent line. And this is our graph of y equals f of x, whatever it may be. In this case, it's y equals 1 over x, but it's like general schematic diagrams I'm drawing here. Now, the thing is that we know that slope of tangent is f prime at a. And a is actually the x-coordinate of point of tangency. Now, the slope of the normal is negative reciprocal of the slope of tangent because obviously they are perpendicular to one another. And that's the reason why it is like that. We know that when two lines are perpendicular, the slopes are negative reciprocals. So that means that negative 1 over f prime at a would be the slope of the normal line. So for this, we're going to say slope of tangent is f prime at negative 2. But what is f prime of x to begin with? The root of 1 over x is negative 1 over x squared. I will let you figure out why it is like that using all the knowledge of differentiation rules that you have learned. And from there, I'm going to say f prime at a is negative 1 over negative 2 squared, which is negative a quarter. So if you ask me what is the slope of tangent, or f prime at negative 2, I'm going to say that is negative a quarter, okay? But that is not the slope of the normal line. The slope of normal is negative reciprocal of slope of tangent. So it's going to be negative 1 over negative a quarter, which would be positive 4 actually. So the slope of normal is positive 4. The tangent line is falling from left to right. The slope is negative 1 over 4, but the normal line is rising from left to right, and the slope is positive 4. And writing the equation of normal would not be that difficult. Again, from grade 10 math, we're going to say y minus y1 equals slope of normal times x minus x1. So we say 4 times x minus 2 and y minus, now if you sub in negative 1, it becomes negative 1/2. So here I write negative 1/2. So this point of tangency, if we call it point P, has an x coordinate of negative 2 and the y coordinate is negative 1/2 because this point lies on the graph. So its coordinates should satisfy the equation of the function. I plug in negative 2 here, so 1 over negative 2 is negative 1/2. That's the y coordinate of point of tangency. So now to simplify, I think you can say 4x and then plus 8, right? And then minus 1/2 equals y. So then you go y equals 4x, 4x plus 8 minus 1/2. It's going to be 15 over 2. All right. So 4x plus 15 over 2 is the equation of the normal line. Okay. So in this lecture, we learned how to find the slope of tangent, either using the limits or by using differentiation rules. We learned how to write the equation of a tangent line. We learned what a normal line is. We learned what the formula is to find the slope of the normal, and that is the negative reciprocal of the slope of tangent line. And also we did one exercise where we actually wrote the equation of the normal line to that graph of y equals 1 over x, and this was the answer. Okay, so this was just a couple of problem-solving questions I wanted to share with you, and I want you to keep practicing. Thank you.